Hello, it's Basil Butcher, your neuroathletic coach. And today I'm doing a little presentation about back pain, and it's called From Injury to the Playing Field, a brain-based approach to resolving back pain. This is part one of this presentation, and this is a preview of my upcoming online classes that I'll be having that are called From Injury to the Playing Field, where clients will be able to be in small groups to work with me, and those who have back pain, I'll be doing stuff for back pain. I'll be doing stuff for shoulder pain, and I'll be doing stuff for knee pain. So there'll be a separate class for each one of those. So look out for the announcement as to when I'll be launching. Let's get started. Three things that I look for. Somebody comes to me with back pain. The top three things I look for initially are their vision, vestibular, and the movement of the lumbar spine. And so we'll get into that. Why we look at the vision? Majority of information or input that comes to the brain about movement comes from your vision. Next on that totem pole is vestibular or your balance system. And three, movement is a big deal because oftentimes people who have back pain, their lumbar spine doesn't move. They don't move their lumbar spine. It's stuck in one position, right? And they move from elsewhere above the lumbar spine or below the lumbar spine, right? So one of the things, even with, MRI showing structural damage, I have so many people, once I've helped them to restore movement of their lumbar spine, right away they're like, wow, my pain is gone, like magic, and it really isn't magic. It's what I've done is we have restored movement maps to the brain. So the brain is no longer, that's not a threatening thing to the brain. So as we all understand today, pain is something that happens in the brain. It's not based on structural deficits. Vision training for back pain. These are three tools that we use. Fast-paced horizontal saccades, short and fast burst pursuits, and memory saccades. These drills stimulate greatly reflexive stability, the cerebellum, as well as improving sensory input from the feet up. So therefore, there's more sensory information coming from your feet, and better function of your feet means the rest of your body is going to work well. And if your back you're having problems with your back, that's a huge deal. Saccades look like this. Sorry, this is just a basic what saccades would look like. I have my two fingers on each side. I'm looking straight ahead, and I switch my eyes back and forth between the two fingers, looking at the target, and that's what a horizontal saccade. Fast-paced horizontal saccades means that you're going to be doing that at an up tempo. Usually we do it around 120 beats a minute using a metronome. Short and fast burst pursuits. Pursuits is where you're tracking something with your eye. So look like something like this. Very short. Memory saccades, just as I spoke about saccades, we would use different apps where the person would be looking at the screen and stuff would appear in the screen and then disappear. And they have to point out where that was. So that's memory saccades. And that plays a huge role in stimulating the cortex, which is a big participant in the control of movement on the opposite side of the body, depending which cortex it is, as well as it enhances, again, midline stability. Vestibular and cerebellum training for back pain. These are some of the tools that we use. Bone conduction stimulation. That's where we use these headphones that don't go into the ear. They go right here on the temple, and different frequencies. You can stimulate different aspects of the vestibular system, the saccules in particular, that plays that gives information as to where the brain is where the head is when you're moving your head forward or back or side to side, as well as up and down. Integrated VSR drills. That's VSR stands for vestibular spinal reflex. These are drills also stimulating the vestibular system. And why we say vestibular and cerebellum training, because oftentimes it's almost impossible to detect the stimulation of which one of the two have been stimulated, particularly when we speak of the part of the cerebellum that facilitates spinal stability or midline stability. And we have lumbar and lower body isometrics. These would stimulate the cerebellum for midline stability. Jaw movements also does the same thing, as well as air hunger drills. Now we move to movement individualization assessment, LFSR. That's lumbar flexion rotation, and LEFR is lumbar extension rotation. These are the LFSRS. These are people who tend to show significantly decreased hip flexion with excessive lumbar flexion during trunk flexion. And LERS, these are people who tend to have a smaller maximal flexion and greater hip flexion in compared to LFRS clients. So these are people, when you ask them to bend forward, they move primarily just from their hips, and there's little to no movement in their lumbar spine, and all the rest of the movement comes from the thoracic spine and the rest of their spine as they're bending over. Lateralization. There are why this is important. You often have people who you see people, they have very little control of their trunk in movement, right? So when they move their trunk, the areas of their brain that are supposed to be stimulated, so it automatically will make adjustments for the trunk to stay balanced in movement. That's not happening. And they would use all kinds of other skills, if you will, like bracing to try to hold their trunk in space, when that's a automatic thing. You don't have to brace when you move to hold your trunk in space. So you want to look at those things to see as well. And then you have and that's mainly controlled by the right side of the brain, the right hemisphere. And then intentional trunk movements, when you ask somebody to do it and they're struggling, are organized and executed mainly by the left hemisphere. So if you can detect between one or the other, if the person has that issue also, you will then appropriately stimulate that side of the brain so that would be upregulated. So that will facilitate the control of the trunk, either involuntary or voluntarily, or when you do for automatic adjustments. And centralization. That's where you're trying to make sure the person, whatever pain they're feeling, is moving from the periphery to proximal, right? You don't want any sensations or whatever to stay periphery. Once they're moving proximal, which is moving towards the center, means you're moving in the right direction. Moving for back pain motor control. These are some of the drills and tools that we use. Direction specificity, that means the person can move their spine on command in various directions. Decompression, that's somebody who can move. You want to train to move their spine so they can be able to decompress the different lumbar segments. Differentiation, that's being able to move your lumbar segments one after each other and not as a whole, as well as moving your lumbar spine independent of moving your hips or your pelvis or your sacrum and so on and so forth. You want to be able to have that control. Or even to also your thoracic spine. And these are some of the movement drills that we use. Spinal lengthening, that's where we're talking about that decompression. Lumbar circles, that's where you're talking about that the direction specificity as well as differentiation. Same thing with lumbar lateral glides. Same thing with thoracic circles and glides. We are encompassing those two things, specificity and differentiation with those drills. Similarly, the same thing here, pelvic tilts and circles, four position hip circles, 6 position ankle circles, and lateral and medial ankle tilts. So you're seeing here, there's an importance of movement from the feet up, being able to differentiate those movements so that you don't move as a block and develop those motor skills of being able to control movement. So when you move it with an integrated movement pattern, you're able to have a proper summation of forces. Then we have neuromechanics. These are nerves that innervate specific areas that affect people with back pain. The tibial nerve is also a branch of the sciatic nerve. The fibular nerve, that's a branch also that branches off the sciatic nerve. That runs down the side of the lower leg. The femoral nerve, that's running down the quads, innervate the quad muscles. The cluneal nerve, that's a sensory nerve for the glute area, right? And these are where the neuromechanics means that we would put tension on the nerves. So all the muscles that are innervated by these nerves are going to be upregulated and contract harder. Or if a nerve is stuck, we can use technique we call sliding of the nerve, so we can get the nerve from no longer being impinged in the area it may have been impinged. So these are very important tools for enhancing movement somebody with back pain. ACM, these are assisted contractile mapping. These are muscles that are frequently underactive or not function as they should when you see people with back pain, and it's to restore those contractile maps. You're supposed to be able to contract those muscles from attachment to attachment, the entire length of the muscle, be able to do so. And that's what these exercises, these specific muscles, we would go through, where you take the muscle through how the muscle would be stretched through all the movements, things that would move for it to stretch, and then all the things that would be moving towards each other, joints, to fully contract it. So you have a full profile of the muscle from fully in an eccentric lengthening to concentric shortening. And then we can use several different contractile tools to enhance the function of that muscle, whether it's isometrics, yielding or overcoming isometrics, long hole isometrics. As well as we can also do slow movements of these muscles, moving them very, moving the joints that attach these muscles attached to very, very slowly. So that's another way you can use to develop local muscle endurance of all of these muscles. And just to point something out, oftentimes you have fast bowlers. This example just reminded me, fast bowlers in cricket, where they have issues with their back, whether it's stress fractures and so on. And one of the things I wonder how much it's looked at, are these guys or these players have the ability to move their spine, have that motor control to move the segments of their spine appropriately to facilitate their action, or are they moving parts of their spine inappropriately, which leads to injury? So that's something to think about. And if you have any questions, you can put them in the comments, or you can contact me about information if you want to know how to work with me. So until then, look out for part 2 and have a great day.